Next up. So my name is David+Rook. Thank you very much for coming to my talk this afternoon. I'm going to be talking about a code review tool that I've developed called Agnisio. So the presentation will go over a few different things related to security code review. But to start off with, I just wanted to introduce myself. So as I said, my name is David+Rook. I live and work in Ireland for a company called Relax Payments. So we're a payment gateway. And obviously that involves credit cards, so PCI. I promise that'll be the last time I mention PCI today. Because I try to avoid it if I can as well. But I work as an application security analyst within Relax. So I manage everything to do with application security, from owning, I guess, the problem of application security through to managing our application security resources, as well as doing the more fun stuff like security code reviews, pen testing, threat modeling, and so on. I think most people probably know me better as Security Ninja, either on Twitter or through the Security Ninja website. So if you follow me on Twitter, you can put a face to the name now. Lots of other stuff as well, but the most important one is the one at the bottom, Agnisio, which is the tool we're going to take a look at today. So, a quick agenda I wanted to run through was firstly a quick look at what is static analysis, or code review, to put it into probably a more understandable term. And probably more importantly, to understand what I think static analysis is, so probably some later parts of the presentation make a bit more sense. I want to take a look at what I call the good, the bad, and the ugly of security code reviews, or more specifically, security code review processes, how people get to review code, how they approach that process, and how they handle that. Then, quickly touching on something called the principles of secure development. The principles of secure development is kind of a whole presentation by itself, so 1 or 2 slides today. It's important just to understand what I mean when I say the principles approach. That's all we need to know for today, but if you go to the Security Ninja website, there's full presentations and so on that. And then we'll jump in and take a look at Agnisio. So we've got demonstrations of static analysis tools near the start, and then we're going to take a look at Agnisio and the new version of Agnisio near the end of the talk. So firstly, what do I mean by static analysis? Well, ultimately I mean a review of source code without executing the application itself. More specifically for today, I'm talking about reviewing the source code of an application to find security vulnerabilities. When you say it like that, it sounds pretty easy, right? But as Win touched on in his talk this morning, one of the reasons maybe Apple doesn't do in-depth code reviews is because finding security vulnerabilities in code is actually quite difficult. And we'll touch on that in the next few slides of how you can try and make it less difficult, but the things you always have to keep in mind. We can either have a manual code review or we can automate it. What we're going to look at now is kind of how much human should you use and how much software should you use for your security code reviews. So I pose a question there essentially of, do you use a human or do you use software? I'll tell you the answer before we go through the next few slides. The answer is, it shouldn't be a question of one or the other. What you need to consider is the limitations of a human doing a security code review and the limitations of using a piece of software to do a security code review. And the limitations are what we're going to look at in the next few slides. Now, the reason I look at limitations is, I guess, one of my approaches to things in life is to not necessarily look at all the good things something can do, but to try and understand the things it can't do. So what are the limitations of me saying I'm going to use a human for security code reviews? And what are the limitations of me saying I'm going to use a piece of software? As I said, we'll look at that in the next few slides. So firstly, using a human, well, the best thing about using the human is that they aren't software, right? And what I mean specifically in the context of security code reviews is that the human can find things a piece of software can't, but it can also understand the context of its findings. It can also give more immediate feedback. It is more likely for the human reviewer not to generate hundreds, thousands, tens of thousands of false positives. So the human has benefits. But then the worst thing about humans is that they are humans. And the problem with using humans for security code reviews in particular, or for today at least, is that the human brain is the limiting factor. So it's not like a piece of hardware you can put a bit more memory or a new processor in it. When the limitation is the human brain, or more specifically, the amount of time a human can spend concentrating on a difficult task, then there isn't too much you can do to improve that. So, roughly, humans can concentrate on a difficult task for somewhere between 30 and 90 minutes before their effectiveness drops off. So that has an impact on the cost of using a human for security code reviews, right? Now, the two graphs I'm going to show you in this slide and the next slide are from a bigger piece of research called 11 Proven Practices for Peer Review. There's a link at the bottom of the screen, but if you Google 11 Proven Practices for Peer Review, you'll find the full report. It was done by a company called SmartBear Software, and they did this research at Cisco. So they analysed, I think it was 2,500 code reviews, covering 3.2 million lines of code in Cisco, and then published all of their information for free. So you can get it all online for free. And there are a lot of very interesting findings in the report. So we just talked about the limitations of a human's ability to concentrate, even a very well-trained human. But the problem is they also can't review much code in one go, or can't review code very well in one sitting either. What this report found was that once a human started to review more than 400 lines of code in a single sitting, they pretty much stopped finding issues. So you can see the blue dots on the graph are what is called a defect density, which is normally the amount of bugs found divided by the lines of code. In this case, divided by per 1,000 lines of code. And you can see the more lines of code being reviewed, the less dots. And you can see pretty much once they got past 400, they stopped finding them completely, apart from a couple of exceptions there. So if we're saying they can do 400 lines of code and they can do that in one sitting, the next question surely has to be, well, how long does 400 lines of code take a human to review properly? Well, again, that was another finding in this report. And you can see from the red line, it is pretty obvious that once a human gets past about 500 lines of code in an hour, it isn't quite as dramatic as the previous slide, but you can see a pretty substantial difference in those blue dots. They tend to stop finding vulnerabilities once they get past, say, 500 lines of code in an hour. So if we take the average working day, say 8 hours, and we're saying that a human can concentrate, and that was another finding of this report, was they backed up that 30 to 90 minutes concentration ability. So if we round all of this up and we're saying our human reviewer can do 400 lines of code, and then they can only do that for 60 minutes. Because they're concentrating for 60 minutes, they probably need time away from reviewing code after that hour. So let's say at the very best, a human reviewer can review code for half of his time that he's in the office, 4 hours. So we're looking somewhere around 1,500 to 1,600 lines of code a day, 6,000 a week, or 12,000 in 2 weeks. And the reason I picked 12,000 is because I can give you a comparison between a human reviewer and a piece of software for that number. Ignicio version 1 was around about 12,000 lines of code, primarily because I'm a pretty bad programmer, but regardless it was 12,000 lines of code. So we're now saying that a human reviewer is going to take 2 working weeks to review that much code, right? Now I use the open source scanning service from a company called Veracode. It completed its scan of Ignicio in less than 24 hours. So you can already see there's a pretty big cost associated with human reviewers, even though we acknowledge they have benefits over software. So we know already that the tools can cover more code in a shorter amount of time than a human. That's probably not really a surprise to any of us. So the best things about software is that it isn't a human. it doesn't suffer from those same limitations. It can run out of memory like a human, but that's, dealing with better spec hardware maybe rather than limitations of the human brain. So the software can be left to run for hours, days, weeks, months, probably even years, I guess, and cover tens, hundreds, or even millions of lines of code significantly faster than the human reviewer. But the problem is with static analysis tools, and in my opinion there are quite a few problems with static analysis tools. They do good, but like I said, I like to look at the limitations of things. So the worst thing about software is that it is software, and static analysis software, from my experience, tends to be very expensive. Relex are a company of about 90 staff, developers about 20. Application security analysts, about 3. We were quoted by one of the major static analysis vendors, nearly €250,000 for static analysis solution. That's way too expensive for us. And the problem is with static analysis solutions as well is you pay that initial licensing fee, and it often costs just as much again to get it implemented, because these tools shouldn't be used out of the box. You almost have to take them through kind of like a learning process. You have to modify them, you have to configure them, you have to tune them. You also have to figure and answer questions like, who's going to manage this thing? Who's going to every morning review that big list of findings from the nightly build? How are you going to prioritize them? How are you going to get people to work on them? All of those issues have to be considered. So there's a big cost with licensing and a big cost of implementation. One of the other issues as well is a large amount of false positives. Now, what I've seen people do in the past is throw out crazy figures for false positives for static analysis tools with almost no evidence to back that up. So I'm not going to do that today. I'm going to show you a couple of demonstrations so you can make your own decisions and own ideas on that. All I will say is, that they're good, but understand the limitations and understand that false positives are absolutely possible. Again, that's not too difficult for us to understand, I guess. Okay, so this is one really simple piece of code, right? So really what we need to concentrate on this example is firstly this line. We're taking a parameter from a HTTP request, right, called name. And then at this line here, sorry it's not showing too well on the screen, but what we're doing here is this is a SQL query. We're taking that input, putting it in a SQL query, SQL injection, right? Real simple example. So the two tools I want to show you is find bugs, which some of you might be aware of. And to be fair to find bugs, it is quite limited from a security point of view, but I find it useful anyway. So if we run find bugs here, you can see it's put this little red bug next to here. And basically what it says at this line is you've got a prepared statement and you've generated it from a non-constant string. In English, you've got a SQL injection vulnerability, right? So you can see even with that finding, it found the issue, but that's not necessarily a finding you'll put straight in front of one of your developers. You probably still need to look at it, analyze it, translate it maybe even, and then give that to the developer. Now a second tool I like to use, and I'm not trying to say these tools are bad, I recommend you try them out. This tool called Code Pro Tools. It used to be a commercial solution. Google bought it. You can get the plugin for free for Eclipse now. And this has something like 80 or 90 different security checks, but you can also see it does a lot of other things, so you can get metrics and so on. The metrics count is actually quite useful because it gives you accurate lines of code count in a piece of code. And we already know from the earlier slides how much a human can review. So you can start to say, well, I can do 1,600 lines of code in a day, then this project is X amount of lines, so it's going to take me a certain amount of days to review it. So we run the security checks, and you can see it finds a few issues, but it doesn't find what we've already said is a pretty simple SQL injection vulnerability, right? So like I said, I'm not trying to say either of these tools is great or either of these tools are terrible, but you do need to understand that even sometimes simple issues won't be found by the tools. Again, another pretty simple example here. So just concentrate on, I guess, this line here, where we're taking in another value. It's called name again. And then we put it into this line here. So we're using a user-supplied value as part of this file command. So we're looking at things like maybe directory traversal, path manipulation is what one of these tools will call it in a second. But again, it's really a pretty simple unvalidated input being used, right? Again, not the world's most difficult vulnerability to find, even for a human reviewer. So you can see find bugs runs now and says, I didn't find anything. So you can start to see already that you might all of a sudden think one tool is great, but then it might let you down. We run the security check here, and you can see here, CodePro tool says you've got a path manipulation vulnerability. And it does explain it a bit more down here, but Eclipse doesn't want to fit on the screen. But you can see it's put this little red flag next to it, and that matches up to the type of vulnerability we expect it to see. And then one final example, a very awkwardly written cross-site scripting example. Awkwardly written on purpose, I must add, because I've used this question in the past in an interview, but I wanted to see how a piece of software would react to it. And again, we have an HTTP request and we have a response, and really this line is the one you need to look at. But again, what we're doing is we're taking a piece of data from the request and just printing that straight out as part of the response. You're thinking things like maybe reflected cross-site scripting or vulnerabilities like that. And if you saw the talk earlier this morning, then you should know that you really want to be looking out for cross-site scripting issues. So find bugs runs, it doesn't find anything. And then I think we'll find the same if we run CodePro tools, that it also finds nothing. So it finds a few things, but doesn't find the vulnerability we're looking for. So, as I said, they're pretty simple vulnerabilities, right? None of those were really complex. They weren't spread over multiple files or anything like that. They were pretty simple. Sorry, I'll skip past these. If you download the slides off my website afterwards, it has all of the demonstrations in there as well. So, the next bit is what I call the good, the bad, and the ugly code review process. I confess that I mainly called it that because I liked the idea of including the good, the bad, and the ugly in a presentation, but it kind of matches up nicely. So firstly, the ugly review process. And I specifically call it a review process because you have to think with a wider scope than just that hour where you sit down and look at code. You need to think of how that code gets to you. How is the developer even being told to write secure code in this process? But at least this ugly review process implies that you actually do review code in the first place, which is better than nothing, right? But these ugly review processes tend to mean that you have an unplanned magical mystery tour of a code review at the end of the SDLC. Now, I'm sure you've probably all heard of the Beatles, the pop group from, I think, the 60s. Now, the reason I used magical mystery tour in that line there was on purpose, because when the Beatles released a film called The Magical Mystery Tour, a lot of people said the plot and the storyline was rubbish. It was absolutely terrible. So what Ringo Starr said, who was the drummer for the Beatles, he said, well, that doesn't really surprise me, because when we sat down and asked Paul McCartney to come up with a plot, he'd come in with this white piece of paper with a circle on it, and he said, we're going to start here and do something here to get there. And that was the plot. Now, if your code review process in any way looks like that, then I'm afraid to say you've got an ugly code review process. These ugly review processes tend to be unstructured and not repeatable because you tend to get grabbed by someone about an hour before they want to put something live into production, right at the end of the SDLC. You don't have time to be structured and repeatable. You sit down and you think, oh my God, what is a security code review? And then you spend another half an hour Googling security code review. You might come across the OS code review guide, which I highly recommend actually. And then you start thinking about it, and before you know it, it's 10 minutes before go live and you haven't even started on those 50,000 lines of code. Even if you had enough notice, the problem is the ugly review process is too late in your development life cycle. You're doing it right at the very end, where anything you find is very expensive. Because anything you find that is a big enough risk delays that being rolled out, right? Which means if it has to be fixed, it has to go right the way back to the development phase. It has to be fixed, has to be tested, has to go through user acceptance, all those things again before they can get back to that final step. What you tend to find as well that these are completely manual process. There's not even a consideration of including any kind of tools in these processes. Then you also tend to get no audit trails. So how can you prove you did reviews? You get no metrics. So how can you prove over time that you're getting better, or a particular developer or a particular application isn't getting better? So I'd argue with your ugly review process, you might have no security at all. Actually, what you might have is a false sense of security, because someone up the chain is telling the CEO or the CSO that, yeah, we're doing security code reviews. Little do they know it's an ugly review process where nothing actually gets fixed, right? So I'd argue an ugly review process isn't better than having no review process at all. So the kind of medium or middle ground review process, which I called the bad reviews, and like I said, it was mainly because I wanted to have the good, the bad and the ugly in there. But the bad review process might actually be fine for some companies. But again, it's all about what you're happy to accept in terms of risk, of whether it's okay or not. So the bad review process often seem to have a single planned code review at the end of your SDLC. So sure, it's at the end of the SDLC still, but it's planned. And because they're planning for that, you know that's coming. So then you have time to put some structure in place, to get maybe some kind of checklist in place for your code reviews. You know, they're normally based on looking for things like the OS top 10. But again, that's better than nothing. What you will find, though, is these are probably still too late in the SDLC. Or, more specifically, if you have a bad review process where you only have the commitment to do one security code review, you, as a security professional, actually have a really tough decision to make. Because you're being told we can budget and put in one security code review per release. So what that means is, do you do your review when the development phase finishes, where the cost of fixing issues is quite small and quite cheap? Or do you do your code review at the end of the QA process, where you're seeing the final code, but you're taking a risk of your findings being so expensive they don't actually get fixed? It's a tough one, because it's a risk either way. You do your review at the end of the development phase, you're not reviewing the code that goes to production. You're reviewing most of the code that goes to production, but not the code that actually goes live. You do it after QA and you run the risk of your findings not being fixed. It's a juggling act. What we tend to see with these bad review processes, we get some automation in there. Usually more basic code analysis tools, which ultimately is what Agnisio is at the moment, and I'll show you a bit more of that later. But we start to have some automation in there to help the human reviewer. We start to then get basic audit trails. Metrics are still difficult to get at this point. They're better than ugly reviews, like I said, and they might be fine for some. Now, the good review processes, and this is obviously just my opinion of what a good review process is. Other people, if you've got different opinions, then speak to me. The good review processes don't happen by accident. This isn't your kind of starting point, I guess, for security code reviews. If you're leaving here today and trying to start, from nothing, don't try and start with doing this. Start with something else and build up to this. Because this kind of good review process even took me a few years of incremental improvements and getting the business to concede ground almost on, we do need 2 reviews now then. Or we need to spend some money on more resources. We need to spend money on, we just need to accept the fact that developments will take a bit longer now. All of those kind of things. And you're probably not going to get that if you walk in tomorrow and try and get people to implement all of this. But the good review process tend to have multiple reviews, so we don't have that juggling act anymore. We have one at the end of development. We have one at the end of testing. So you're seeing code where you review and should find most of your issues at the end of development. Those things should get fixed. Then it goes to QA, and there's normally a few cycles, right? QA find things, developers change things, blah, blah, blah. And then you do another review where you're just comparing the changes, really, between what you reviewed earlier what's going to production. So the chances of finding anything should be quite low. Again, depends on how good your developers are, I guess. They become very structured, repeatable. There's a process around not just writing software and delivering pieces of software, but a process around how you review code. And I've said in there with management support, and we all know you need management support to do security right. But what I wanted to share with you was my experience of management support. When you think of maybe even in bigger companies than the one I work in, it's in some ways easy for a CEO to say, we're going to do everything secure. He then puts pressure on the development team, on whoever owns development and products, to deliver things quickly, to go to agile and all these kind of things. And then you're stood there as a security person saying to him, well, actually, you can't do it much faster because we still need to have these security deliverables in there. So I found it's in some ways more important to get that kind of local management buy-in, the product managers, the developers, the QA team. Obviously you need upper management support, but there's a different kind of sales pitch you need to make to that local management. You have reviews as exit criteria, and we use automation where we find it useful. Now, it would have been easy for me to say we use lots of automation, but we've already seen that for some issues, both of my tools didn't find it. So we can't rely too much on that. You need to understand where it's useful and use it where it's going to help you. We then start to get to a point where we can produce reports, metrics, and so on. And then one of the last things there that we introduced at Relex in the last couple of years is we have an external company come in, not necessarily a security company, but more of a process company, process auditing, So they come in and they look at our SDLC as a whole, as a process, and then take a couple of projects we've delivered and audit them against that. And then they audit our security code review process. And that kind of was one of the starting reasons for me developing Ignicio. So I just want to quickly fly through these next couple of slides because you only need to know a little bit about this today. So the principles of secure development. A few years ago, I got quite annoyed around how a lot of people were trying to teach developers how to write secure code by just showing them how to exploit vulnerabilities. I said, if you want people to write secure code, you need to tell them what they need to know. What do they need to do right in their code rather than what an attacker might do? You still need to have an element of showing them the vulnerabilities, but you need to show them how to write secure code if that's ultimately what you want them to do. So I went away and I looked at all of these vulnerability lists, the OS top 10, SANS top 25, all those good lists, don't get me wrong. I just think sometimes they're used incorrectly. And what I did is I analysed all of the vulnerabilities on those lists and tried to understand, what does the developer have to get right to prevent that vulnerability? Things like input validation would knock, I think it was a third or more of the vulnerabilities off the OS top 10 and SANS top 25. Sure, that doesn't mean input validation is easy, but it means you're teaching the developers about what they need to know. And over time, I started to think of it a little bit like this well-known saying on the screen. The saying is, give a man a fish and you feed him for a day. Teach him to fish and you feed him for a lifetime. So I wanted to apply that initially to secure development education. So if you teach a developer about a vulnerability, they'll probably be able to prevent it. But if you teach them how to develop securely, they should be able to prevent many vulnerabilities, right? It's all about teaching them what they need to know to achieve what you want them to achieve. Okay? It means that it's, from a security person's point of view, it means that your job is harder because you have to go and figure out how are you going to give them training that they find useful. Training where they're looking at code, they might be looking for vulnerabilities in code. And just to put that a bit more visually, I took the OS top 10, SANS top 25 list, and White Hat Security top 10. There's loads of others, and like I said, I'm not trying to pick on anyone in particular. And that's 45 vulnerabilities between those lists, and 41 of them had unique names. They didn't even call cross-site scripting the same thing across 3 lists. So I thought that's confusing. So do you want to try and teach all of these, or do you want to teach the developer what they need to know? The principles of secure development on the screen now is basically the route the output of doing that root cause analysis on all those common vulnerabilities. Over time, I wanted to make the principles approach more useful. So if I'm teaching the developer the principles approach, and that's how they're writing their code, well, then I should be mapping my code review process to the principles. And you'll see that in Agnitio a bit later on. As I said, lots of stuff on the principles on the Security Ninja website. So, what is Agnitio? Well, it's a tool that tries to help with those limitations of the human reviewer. It's there to try and guide and help a human perform a security code review. And I guess initially it was just an application that formalized a checklist-based review. And I'll come on to that a little bit more in a second. But it also now includes a lot of kind of education and guidance material. So all of the information about the principles of secure development is also in the tool. So you can just click onto another tab and get the information you need when you need it. It automatically produces your audit trails, your integrity checks, your code review reports, and your metrics for you. So just before I move on to Agnitio, I did say it is an application for doing checklists. I know that sounds pretty boring, especially after some of the other presentations we've had today. But checklists are important, whether people think they're too smart for checklists or not. I always beg to differ with anyone who says to me they don't need a checklist to do their job correctly. And I usually use the examples of doctors and pilots, and I also use the example of myself in my own job. So does anyone know who the guy on the screen is now? I wouldn't have known until I started looking into this presentation more, if I'm honest. His name is Dr. Gawande, and he wrote a book called The Checklist Manifesto. As far as checklist books go, it is very good. And what he did was he looked at checklists and how they're used in hospitals. And what he figured out was that by introducing checklists, people who were seen as experts and really good at their jobs actually became experts. And what I mean by that is that he found that many of the mistakes that were made in hospitals were made not because people didn't know how to prevent that, but because the things that they missed were so simple, they didn't think of them. Sounds crazy, doesn't it? But that's what he found. So what Dr. Gawande did is he actually made, believe it or not, a checklist for creating checklists. And to cut a long story short, this has brought him a lot of success. He's an advisor to the World Health Organization, among other things. His book, The Checklist Manifesto, was a bestseller, New York Times, all of the big bestseller lists, he was on it. So what he did with his checklists to make checklists was he made checklists. So the one here is for heart surgery. Now when I saw this, I thought, well, if someone who might be cutting my heart open needs a checklist, then I'm not going to dispute the fact that I need one for a security code review, right? And as I said, it's all about making people think of the simple things to check. The guy who's operating on you, he knows how to operate on a heart. But he needs a checklist for him to ask you if you have an allergy. And right in the middle there, he's got a checklist item to ask if he's going to put ice on your head. Pretty simple check, right? But if he doesn't do that simple check, then the allergy one in particular, you might end up dead. So you'll be glad he had a simple checklist. And this is another one that they produced for Cessna aeroplanes. And if you want an example of a really simple check on a checklist, take a look at the one in the very top corner up there. There's a checklist item for the pilot to check the fuel in the plane. Now, pilots are not stupid people, but if they need a checklist to tell them to check something like that, then again, I'm not going to argue about making my staff use a checklist for security code reviews. And you can see that checklist is actually quite comprehensive. It takes it from, the second he steps on the plane, right the way through to taking off, he's landing, and when he gets out of it at the very end. So, I assume by now everyone who isn't using checklists at the moment might go and implement checklists themselves. But if you don't use checklists, what's the worst that could go wrong? We all know about security vulnerabilities and, not finding them in code, but I wanted to show, I guess, some more extreme examples of simple things that weren't found in source code that sadly led to actually people dying and over $1 billion worth of equipment being destroyed. There are 3 different examples. You might have heard of some of them. So the first one here was the Ariane 5 rocket, in particular Flight 501. Now, these few examples, there's never one single root cause, but one of the biggest issues for this particular version of the Ariane 5 rocket was that it would take a 64-bit floating point value and try and convert that to a 16-bit integer value, causing an overflow, of course. Now, we've seen today already what an overflow, buffer overflow in particular, can do for you with a piece of software. What do you think happens when you have an overflow in a space rocket? Well, sadly, Ariane found out after about 37 seconds into the flight what happens when you have an overflow in a space rocket. It started to veer off course because it had some crazy number to try and calculate for something in the system. Its auto-destruct sequence kicked in and it exploded. In the notes of these slides is the links to the official reports, but if you Google the name of these slides, so Ariane 5 Flight 501, you'll find all the information yourselves. Now, this is quite a sad case of an X-ray machine which had loads of different software issues in it that led to people being given doses of radiation 100 times more than they should have got. And there were 3 or 4 people killed by this machine. Loads of people with radiation burns. And loads of simple things wrong with the code. And one of the things the code did was after it did an operation, auto-incremented a variable. When this variable got to a certain size, it caused an overflow condition in the X-ray machine. The overflow in the X-ray machine didn't make it explode like our rocket. What it made the X-ray machine do was ignore the safety controls that should have been protecting the person being X-rayed. It had lots of different issues. It had like a race condition as well, something to do with the operation it was going to carry out. If the operator inputted something different on the panel at a certain time, it would miss that and give the poor patient a wrong dose of radiation. It also handled exceptions incredibly badly. All it would do was it would show on the screen the word malfunction and then the number 1 to 64. Now, the person operating that, they might be a nurse, they might be a doctor, but still, that doesn't mean anyone. That probably doesn't even mean anything to the person who wrote the code, maybe. So the people will just override every single exception, regardless of what it was. Quite a sad case, but you can see, the code bases are probably quite complex for the rocket and for the X-ray machine, but still, they're pretty simple things that were missed, right? The final example here, a pretty embarrassing and expensive example for NASA. Now the total cost of this mission to NASA was $655 million. So the cost of this orbiter, the cost of, the flight command, all of those kind of things. Again, a really simple thing went wrong and cost them all of this money. That they were using a certain unit of measurement for thruster performance in flight control. A piece of software had been developed to use a different unit of measurement. So rather than orbiting nice and safely around Mars at about 220 odd kilometers, it decided it would orbit at around about 57 kilometers. Now, these orbiters, you can see in the picture there, it's a pretty fragile piece of equipment. So when it went in that close to Mars, it just disintegrated. So again, a pretty simple thing that was missed with very expensive consequences. So just back to what's the worst that could happen. And I know these are pretty extreme examples, right? It's not every day, all of us will be programming code for space rockets and X-ray machines. But I wanted to show that doctors and pilots have incredibly simple things to check. The things that went wrong in those 3 examples, I would suggest were pretty simple as well. So, why did I develop Agnitio? Well, you probably would have guessed by now I love using checklists. I've used checklists for security code reviews for a few years now, and I've built ours at work up over a few years as well. I've got to the point where I've been praising checklists so much. We have checklists for security code reviews, peer code reviews. We have checklists for if you modify things like stored procedures, you have to get a SQL administrator to fill in a checklist to check those things as well. And I stand by the fact that if a checklist is good enough for a doctor and a pilot, then it's good enough for our code. But more importantly, what I found was that at Relax I had this good code review process. The one I talked about before is the review process I have at Relax. But I figured that it wasn't smart. And when I started asking myself questions, particularly two on the screen here, was the process really easy to use? Was it easy to be a part of? Was it easily repeatable? Was it easy to audit? Was it easy to produce metrics? Or were we kidding ourselves in saying that we could produce metrics? Could it produce reports? Could it do integrity checks? Well, the answer for me was no at the time. I needed something to make that good review process smart. So as I said, my own review process was good, but it wasn't smart. We had got this multiple review process, producing these reports and so on. But it meant that for every single release, we would do a minimum of 2 code reviews. And then we would produce 3 different pieces of evidence for each code review. And this was me thinking the process was smart until I really sat down and looked at it. So what that meant was, if we wouldn't have been using Agnitio for 2010, we would have done about 400 security code reviews. So we still did 400 security code reviews, but we did them in a smarter way. So instead of opening up like a Word document template with a checklist in it, make sure you don't overwrite the template, make sure you save it in the right project directory, and then still 6 months down the line, how do you explain to an auditor that no one's modified that since you created it? Or how do you really prove that you didn't create that yesterday before the auditor turned up? You struggle when you start getting those kind of questions, right? So what I wanted to do was take the idea that we had around using checklists for code reviews and make things not necessarily easier to do the checklist itself, but make the rest of the review process easier and smarter. So firstly, I can't claim credit for using the idea of application profiles. It was someone much smarter than me came up with a completely different process around, prioritizing risk and so on when it comes to application security. But what I've done here is use that concept of an application profile. So before you do a review, you need to sit down and think about the application you're reviewing. So you need to think about who designed it, who developed it. Does it face the internet or is it internal facing? What types of data does it process? What languages? How sensitive is it? What databases and so on? So I'll just show you a quick one here. So it's really simple. It's just check boxes, drop downs, a bit of text, right? So what we're saying here is this is an application that processes card payments. It's facing the internet. It's using C#, Ruby, XML, whatever. It's a test application, right? What I'd really like to get to in later versions of Agnitio is start to give you kind of suggested risk ratings or suggested pass or fail based on the information in this profile and the answers you give in your checklist. So an example might be, we've got a test application that processes credit card data. We're saying that it's very high importance to the business. But in your code review, you might say, no, it doesn't do input validation. It doesn't have these basic authentication controls or whatever it might be. The only reason I haven't got that in there yet is because everyone seems to score risk completely differently. So until I can find a way of applying a risk score that everyone can be happy with, then I'm not going to spend the time trying to figure out how to code that. But it's definitely on the roadmap because we've got all the information there. We'll have the information from your review. So we should be intelligent about it. We should be able to tell you, okay, well, I'm suggesting that's a risk score of 20, which for your business might mean that's never going live until all that's fixed. But until I can figure out a way to define risk that a lot of people are happy with, I can't really do too much of that. So once you have an application profile defined, you come onto this tab and then you just fill in the information at the top, click start, and then you get the checklist. And the thing to remember is this is a checklist that I use, this is an application that I use, so it's in my own interest to keep on developing it and making it better. But basically you have, in this version, I think 66 different questions, and you can see in the column after the question number, the principals' names that we touched on before, right? So you can go through this review, tick the answers, blah, 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 put in some notes down here, lines of code, bugs, and defect density, as we saw right near the start of the presentation. It just calculates that for you automatically. So then you save these reports. But what if, before you save the report, you look at a question and you think, actually, I'm really not sure what this question means here. Has centralized whitelist approach to input validation been implemented? You might look at that and think, actually, I don't have a clue of what David was thinking of when he wrote that. So, you know the principle that it's mapped to. So how about go and have a look, find out a bit more about input and output validation. You can see the types of vulnerabilities input and output validation can help prevent. You've got a whole section in here talking about input and output validation, best practices, what you should do. And then at the bottom, different code samples. So we've got one for whitelist validation. The one in the middle here is blacklist. And then just a real simple HTML encoding example. If you want to see more on the questions, you can just go in here and pull up any of those questions. So at the moment, those two areas are just things that I've written, right? But I'll show you a bit later on. Version 2 is going to allow you to edit all of those. So you can start using your languages, your terms, your libraries, your own questions even in this tool. Because what I deem as a good security code review checklist, you might not think is appropriate. You know, we use a lot of XML at Relex, so there's questions in there around using XML schemas. If you don't use XML, you don't really want to be asking that question, right? Because you'll just be forever ticking NA on that question. So, quickly onto the next slide. So as I said, we were producing crazy amounts of Word documents. So if you think we had 2 Word documents for every single code review, times 2 for every release, which meant that we were producing 4 Word documents for every release. It starts to become a bit ridiculous at that point. You know, there's a checklist Word document and then there's a general kind of security code review report. Without Ignitio, we would have had to have generated 800 Word documents. Now that's a lot, and I decided enough is enough. We've done the hard work of doing the review in the first place and completing the checklist. So we shouldn't have to work hard to produce a report, right? So if we go into here, you can at any time pick whatever version of the code you want and just click View Report. And it shows you a read-only version of the report you've just saved or saved whenever. And then from this drop-down, you can decide, did it pass, did it fail? So you can pick one of those, click the floppy disk icon. Again, that was quite a confusing one, actually. I'm not a UI guy at all. But to try and find an icon that everyone would understand as save was harder than I thought it would be. So when you click save, it tells you that it's exported it and it's created the report for you. Now, because I already had a version of that report saved, I get a slightly different message here. But when Ignitio saves your code review report, it takes a hash of the report contents and then stores that in a verification table. So when that auditor comes to you next year and asks, how did you prove to me that you didn't edit that yesterday? Well, what you can do is load in any of the reports we've saved from Ignitio. So this one here is just the one we've just saved. And when we click verify, it takes a hash of the contents again, compares that to the verification table. If it's got a match, it tells you who reviewed it, what the application was, the version number and the date the report was saved. Now obviously, because you have access to the Ignitio database, if you really wanted to cheat, you could. But if you're going to that level of cheating to get past an audit for code reviews, Ignitio probably isn't the kind of tool you'll be using anyway. Because obviously if you modify the report, you know that it's just a hash of the report contents. You could take that, do an insert in the database. But I didn't tell you that, obviously. Okay. So the final piece of evidence that we used to produce was a notepad file. Pretty basic. We just put things in there like, what files have we reviewed? What bugs have we raised? How many lines of code? All of those kind of things. Which meant when we started to say, yeah, we should generate metrics for application security, we're sitting there with like 400 notepad files. And I said, again, that's just not going to fly. So, what we have, I've preloaded these. I've had trouble with demos in the past, so I didn't want to run into it here. But basically, you pick your application from the drop-down, click load, and then based on the information, you've already done all the hard work to put the information in the database, it generates your metrics for you. So at the moment, you can only review them in the application. But we have a web interface in development for Agnisio. So you can put this web interface anywhere. Tell managers, developers, project managers, whoever, go to this URL and you can view the metrics, you can get your reports and so on. But that should only be another few weeks away. But you can see what this starts to tell you is for the last 5 code reviews, how many lines of code were involved, how many bugs. The central graph actually breaks down the yes, no and NA answers you've given for the past 5 reviews and shows them in this chart. So you can quickly start to see whether, the last 2 reviews were normal or were they out of the normal. So if you've gone from having, from the looks of it here, about 33 no questions, and that jumps to 50 all of a sudden, you can see it very quickly. And then the bottom 2 are kind of working on the average amount of yes, no and NA answers given. So the pie chart is just a breakdown of the yes, no and NA answers given for that application for the past 5 reviews, and then the table in the bottom right just compares each review against the average. So straight away you can see, is this application review better or worse than the average for this application? Okay. So to put that visually, bring everything together from the last few slides. And remember, without Agnisio, every one of those icons would have been multiplied by 10. Okay? So I decided we're not having that. So I brought all of those together into something that I had spent a lot of time naming, the security code review tool. And you can see it looks fairly, familiar. It looks quite a lot like Agnisio you just saw. And when I decided, and when I got the business to agree that we'd release this as an open source tool, I suddenly started to feel a bit self-conscious and thought, actually, that tool looks pretty ugly. So I'm not normally shallow, but I decided I had to make it look a bit nicer before we released it as an open source tool. So that is the Agnisio you've just looked at there. Okay, so moving just quickly on to Agnisio 2. I wanted to release Agnisio 2 today. The problem is, I suffered probably the same as every other project, scope creep. The tool that will be released for version 2 is different than what I planned for version 2. But it's only another few weeks away. And as you can see from the top line, version 2 will be available in French. It'll also be available in Spanish, Portuguese, and I think Italian as well. Initially, we just released it in English because I thought, well, this is an application for checklists. I didn't actually think anyone would be interested in using it. And since we released it last week or last November, we've had 5,000 downloads from nearly 100 different countries. So we've had a lot of call for different languages, and thankfully not so many bugs raised, but loads of feature requests raised. So one of the things I'm trying to work on is to take what we looked at earlier, where we said we need both human and software for our code reviews, and try and put both of those things into Agnisio. So the first version of the automated code analysis module is coming in version 2, and it is pretty basic, very basic in fact, and I'll show you that in a second. I also said that the developer guidance sections that we looked at, the checklists and so on, people were screaming out saying, we want to modify those, which is great, because it means they really want to use it. So all of that will be completely modifiable in version 2. What I will do in a version or 2 after is allow you to basically delete the whole of my checklist if you want, make it longer, remove stuff. For now it's just edit what's there. For the checklist anyway, the guidance sections and so on, you can delete all of that if you want and add whatever you want in. But what I want in some ways to get to with Agnisio is that you can load any checklist into it. It doesn't necessarily have to be a security code review tool, because if you're doing checklists, you essentially have the same requirements. You want to know people are doing it, so you want an audit trail. you probably want to produce some kind of metrics from that process. You also want to have integrity checks so you can prove to auditors that, yeah, we created it then and it hasn't been modified since, or whatever it might be. But that's only something that I've thought of in the last few days, so I don't know when that'll actually happen. And loads of other suggested changes from people. So I want to just quickly show you it now. The UI doesn't look too different. The checklist itself is completely different in the way that it's presented. You probably won't notice that unless you go and check out the code from SourceForge and compare, but there's a huge difference in the way the checklist is drawn, and that's to allow you to edit it, because I made a typical beginner UI developer's mistake in the first version and do all of the checklist stuff as text box. Can you believe that? All of the checklist items were basically text boxes. I'm ashamed to even have to admit that. So now this uses a nice data grid view, so you can make it bigger, smaller, you can put whatever text you want in there. So one of the other limitations of the previous versions of Ignition was the fact that they also hard-coded the two values people probably want to modify: the report path and the database path. The database path contains the reviews, it also contains the questions and, the guidance information. So you can just modify those now, put them wherever you want. And as I said, there's a checklist editor, so you can go in here, it loads up checklists. You can just click into any one of these checklist items and just modify it, so you can delete it, save it, whatever you want. Okay, so like I said, over time I want you to be able to actually completely delete items or add rows in, but for version 2, I didn't want to spend any longer on it, so I want to get this done, and then I'll work on that. And then this other bit that isn't coded yet is going to be connected to the code analysis bit I'm going to show you now. So you'll be able to go in and write your own rules. You'll be able to go in and modify the ones I've created. And in some ways I don't really want to call it static analysis, and I don't really want to call it rules either, because it isn't that complicated in the first version. It really is simple. So what I want to show you is an open source project called Square. It's not Square, the payment device thing. I think it was some really basic CMS. And you can see that when we've scanned that code in here, it's highlighted the PHP get function. So if we click on the get function, it talks about it a bit down the bottom, but I'll move on to that in a second. But you can see that we're getting ID and assigning it to token, yeah? Where does token end up? In our SQL query. And as I said before about simple things being missed, that's something pretty simple. That's what, 3 lines below where you get the value, you put it in a piece of SQL, you haven't validated it. So just in the bottom panel there, you can see that there's a little bit of text explaining why that was highlighted. And more specifically in this line, it says, any values collected from a form must be validated before you use them in any potentially sensitive syncs. So basically, when you get a value, don't use it in that piece of SQL before you validate it. On top of that, and the GUI part of this part of the application will look a bit smarter when it's released. What I want to do then is to link relevant checklist items to the thing you've just found. So let's take this one here. Has all input validation been applied in a whitelisting fashion, etc., etc.? Well, no, we've got no input validation on that value. Okay, I can go straight into here and you can click no for that question, for that review. Like I said, it's not like a commercial static analysis tool, and it still is ultimately a checklist application. But it's making the most of the time you have available as a human to review code. It's telling you the questions you need to ask. It's pointing you to areas of potential risk in the code. The code analysis module might take longer than some of the other areas to develop, because you kind of move on from this kind of grep functionality to crazy stuff like parsing the code into abstract syntax trees, trying to follow the flow of information through the trees. That might be a bit advanced. But that's where I want to take it to. I want it to be the tool. I want it to be the kind of the Swiss Army knife for security code reviews. It might not be the single best solution at any one of the things it's trying to do. But if you know that you open one application and you've got everything you need for that good security code review process, then it has a value. And I always struggled with trying to define what I long-term wanted Agnitio to be, until someone posted this comment on a blog post I wrote about static analysis tools. Actually, you should go and read the comments on that blog post. They actually turned out to be far more entertaining than the blog post itself, because it turns out when you say, well, I suppose not complimentary things about commercial static analysis tools, some of the vendors don't like that. So you can see comments from static analysis vendors there in that blog post as well. Some of them weren't particularly pleased. But what this guy said is, all of these things are really expensive, they're difficult to implement. So what we really need is something like the Burp Suite tool, but for static analysis. Something that's awesome, is powerful in the right hands, and completely affordable. Now, I'm not claiming that Agnitio can deliver on those expectations. I'm certainly not going to stand here and say Agnitio is going to be the Burp Suite of static analysis tools. But what I will say is I'll do everything I can to try and get close to delivering something like that. Because, like I said, it is an open source project, but this is a tool that helps me do my job better when the tool gets better. So it's not going away anytime soon. And then lastly, just to try and help you understand how you can take everything I've gone on about today, maybe not exploding rockets and killer X-ray machines, but the other side of things, how you can take that and apply that yourselves. I'm biased. I think the principles approach, the principles of secure development, is a great way of teaching developers how to write secure code. So I'd say if you're interested in finding out more, on the Security Ninja website there's presentations, there's videos, there's white papers. I think everything you need to be able to take that and start using it yourselves. Try and then focus your secure development education and training on how to write secure code, not how to exploit vulnerabilities. What you then also need to do is in both your training and when you use things like Agnitio, make sure you use your development languages. There's no point if you're a Java development house basing all of your training and examples on PHP. Use the things that your developers are going to work with, and you'll find them much more receptive and open to writing secure code when you show them what they need to know. And then the last two kind of come together, I guess. I'd say if you're going to go to the effort of using the principles approach for training and writing, your whole process around that principles approach, then use Agnitio as well, because you're continuing to reinforce the connection to the principles of secure development, because all of your security findings you can tie back to a relevant principle for the developer. Okay, so there's loads of links up there. Security Ninja I kind of do for my own pleasure, but also it's supported by my company, so there's SlideShare, YouTube, all of those kind of things. There's the website there, and then the second link is the link to Agnitio. If you just Google for Agnitio, it's the third result on Google. I didn't realize there was a company in Spain actually called Agnitio when I picked this name. Agnitio is actually, what I remember, is Latin for recognition and knowledge. And that kind of summed up the tool for me, because it was a recognition of something needed to change, and it was placing the knowledge in the hands of the people who needed it when they needed it. So does anyone have any questions?
I have a question about the static code analysis integrated in your tool.
Yep.
Knowing from experience that static code analysis, which is language independent and really powerful, is a big pain in the ass in terms of implementation, and it's just a live task.
Yep.
So if you've been considering, for example, implementing an API which is capable of speaking to other code analysis tools and just evaluating results and correlating them with the checklist results?
I had thought about it, and I'd spoken a little bit to HP about potentially doing it with Fortify. The problem then is that you take that functionality away from people who can't afford Fortify. And that was the problem, that we looked at things like Fortify and the price tags were too huge. So what I'd like to get to is maybe have that kind of integration, but also have something for people who can't afford that as well. Ultimately, you're right. I looked at using abstract syntax trees and, all of those kind of things, call flow graphs. And it looked incredibly difficult just to do it in one language. So Agnesio might never get there, is probably the realistic statement from me. But I think I can do better than just the grep thing. I just don't know what better means at the moment.
And just wondering, because for PHP, for example, there is RIPS, which is open source and free, and I don't know if there is any good or easy to parse export format, but I think there would be a way to just create some synergy of using that tool's output and putting it into your tool, because both are free and the result combined could be quite great.
Absolutely. That's when I used to present a slightly different version of this presentation. I used RIPS as one of the examples. So if you do PHP and you want a static analysis tool, take a look at a tool called RIPS. It is very good. But yeah, what I'm also trying to avoid is trying to not reinvent the wheel. So I don't really know where the code analysis module is going to end up yet. But yeah, there's loads of different options I need to look at for that.
Thanks.
Any more questions? Okay, thank you very much.